Okay, so welcome back. I'm continuing where I left off. Before I continue, I just want to say, apologize for the part where I did not record. Okay, I think I pressed the recording pause button by accident. So I think there's a big chunk of explanation that was like just missing. And how did I get from somewhere in the middle? Yeah, so everything from when I started writing the number 3, I think you probably would have missed it. So let me go through some of that just quickly. So what I was doing here was to try and get out a derivative, so like to save space and make things neat. However, you have this sort of term here, this delta p x plus delta x, then p of x. This one is not a derivative at all. Fortunately, this term can be used as the so-called other term to make up for that derivative. So what I do here is this: delta p x plus delta x, p of x, minus delta p at x and p evaluated at x. So this term and this term here are exactly the same. So when you introduce a minus here, you need to introduce a plus as well, because you're like adding a 0, so to speak. And this term will combine with this minus half term to give you 2.5 here. Okay, so I say again, you have this term here, which is not exactly an integer. You cannot just reduce this to a derivative. So you need to complement it with another term where you make this finite difference, so to speak. And to do that, to minus this delta p at x and p at x, you need to plus over here. And so this term here becomes a derivative. This term here just gets subtracted from this over here. Okay, and this term here then becomes the derivative, which is p of x. Okay, and then you take the partial derivative of this momentum thickness with respect to x. Now, if you were to do the same trick with this here, and I kind of skipped some steps, so you just repeat whatever I was explaining in the last 2 minutes, then you will get this term over here, 2p delta x, and then this whole term here will go to the right. Okay, now we have this term here, which is a little bit troubling, which either means this term may disappear or not, I'm not sure, or there may have been a careless mistake halfway through. So I'll probably fast forward to search for that careless mistake, and we'll see where things go from there. And guess where the careless mistake is? It's right over here. Okay, so I forgot to put a minus sign here. Okay, let's go back to the part where we take our force equilibrium. Wow, that's a very costly mistake. Okay, and then let's see where everything else has to flow from there. Okay, so no, this is similarity transform. Integral solution is here. Yeah. So look at this force on the right. This should be a minus sign. Okay, minus sign over here. Why is it minus sign? Of course, the magnitude of the force doesn't really matter, but the direction is opposite of the forces on the left. Okay, it should be opposite of the forces on the left. And of course, this force on the bottom is also acting to the left. The force on the top and the force on the left and force on the top are both positive forces pushing in the positive x direction. The forces on the right side, they are pushing towards the left or a negative x direction, and also the forces at the bottom. So I'll need to put 2 negative signs here, and that's actually probably why there was a mistake there. Okay, so let's see how we need to correct everything. Okay, mass balance is quite the same. I believe momentum balance should also be okay. We did take into account for the direction. let's take a look at the sum of forces, which is right over here. Okay, there should be a minus tau and minus p x plus delta x. Right. If this is a minus, then the equation here will be a minus tau and a minus p. Right. Okay. And of course we cancel out the LZ and it will still be the same. You have a minus tau and a minus p at x plus delta x. Alright. Okay, so now that we have that, we can start putting this tau x here. Tau x will be minus, and this minus delta p here should also be a minus. So apologize for the careless mistake. Yeah. But let's keep continuing. Okay. Tau x here again. And you can take the limits. Tau x will be again negative, and this big delta p thing will be negative. Alright. And this will be the same. And you will get those derivatives. Okay. So here will be a limit with a minus tau x here. And you will need a minus delta p delta x. The left hand side, yeah, once we take out the limit, that should be yeah, you can skip ahead of the video if you find this a bit tedious and meaningless. It's just me correcting my careless mistakes. Alright. Let's see. Yeah, but I'm going to continue, as this is necessary anyhow, unfortunately. So we can look at the terms inside the limit. This will be a minus. Okay, and the rest is kind of untouched. 3 and 1, 2, 3, 4, 5, 6. Okay, so let's do another 3. 1, 2, 3. This is one careless mistake. Alright. Let's go down, keep going. 1, 2. 1 and 2, yeah? So let's do this one first. This plus sign will be here. Okay. So now this first one here will be at 0.5, not 1.5 now. It will be 0.5. Or rather, let's let me check. Yeah, you will have a minus delta p. Yeah, you plus it here, so it's a minus 0.5. It's minus 0.5. And you plus it again. Yeah, you plus this delta p x plus delta x over here. Yeah, this whole thing here will plus here, so it will become a plus 0.5. The other will be a minus 0.5. So we'll need to change all of that. Oh boy. There you go. Okay, so now we have this. We can then say this plus 0.5 will need to be matched with another minus 0.5, not minus 1.5. And over here, this will be a grand total of 2. Not 3. Okay, hope the math checks out. Okay, so now these two can be factored out into the half here. And that kind of still leaves us with 1, but let me check. Alright, sorry. This should be a minus 0.5, not a plus 0.5. So, yeah, we had minus P delta P. And then we added half to it. So that should be a minus 0.5. The signs were wrong. Okay, let me go back 1. Yes, so I put a plus minus 0.5 there. Minus 0.5. Okay, never mind. Let me compile this first. Okay, now the math will check out. Okay, this is a minus 0.5. Okay, one more up here. This is minus. Okay, so now we can just take a plus 0.5 and leave the... Okay, we'll leave the 1 in front. Okay, and everything will just cancel out. Whew, that's a lot of work. Okay, this thing will come out as a half derivative here. Okay, half of this, it will be in front over here. Okay, and yeah, this is where it is. We will have half, and there's a minus half, not just half. It's minus half. All right. And this one will be, the 3 will be gone. It will become a 1. So I'll need to change all of this to minus half. Minus 0.5, and the coefficient there will be 3. Well, 3 will be changed into 1. Okay, minus 0.5. Minus 0.5. Oh. Okay. Okay, now we are seeing a lot of this stuff going on. Whew. Okay. Phew. Yeah. So let's see. Alright, where were we? We were over here. So this one should disappear. Okay, 0.5, 0.5. This 2 will disappear and become a half. Okay. So this 2 in front will disappear and become a half. And conveniently, that allows us to take limits. Okay, this one will become a half, and this thing will just disappear. So minus 0.5 here, minus 0.5, minus 0.5, and we are done. Thankfully. Okay. LaTeX is complaining, and I'm complaining about LaTeX complaining. Let's try again. Okay, so this whole two thing should disappear. Okay, let's see whether this works. Okay, so this one will just become a classic derivative here. And this limit at the end, right at the end, will become zilch. Poof. And now I can put minus 0.5 here. And voila, we are almost done. Now we can just apply product rule to this and simplify this this out. Why is there a random s over there? That should not be. Okay. We'll just do a product rule here. Let's do the product rule. Okay. So this will expand out. This will expand out. And is this a plus or minus? I am so... Oh man. Okay. Alright, let's try working the maths out. I hope this works out this time without a correction needed. Okay. Alright, so I need to do a product rule on this. Product rule expansion. So let's do that. So this thing has to be expanded. So I will have two minus signs. Yeah, product rule expansion. Now take one out, and delta P out. Here I'll take the pressure out. And let's do that. Product rule. Wow. Oh man. Okay, so this is me just preparing this for product rule. So one, I'll take the P out. Let's put the P outside. And the other one, we'll put the delta P outside. Just copy and paste. Okay. Right. And that should be proper product rule expansion. Okay, so now we can start cancelling terms. This P, this will cancel with this, and it will cancel with this. So two halves make a 1, and they'll cancel with this. So P delta X will be cancelled. Okay. So let's cancel that. Okay, I don't want to delete the equal sign as well. And here. Alright. And we can combine the two remaining terms together. And that will give us just minus delta P delta X. Ooh, wow. That's a long proof, but it has resulted in a simple result. And that's a very important result that we can substitute back in. Alright. Substitute. back in. Okay, so where are we now? How much time do I have left? Okay, I'm about 20 minutes. Not that much over time. All right, let's just substitute all of this back here. All of this back here. So right after left hand side. Okay, so minus tau x will just become minus tau x, not surprisingly. Minus tau of x, and this delta p delta x. Okay, and that looks neat, and that looks correct too. Okay, and of course we can bring the tau to the other side. Makes it look a little nicer. Now, careless mistakes tends to multiply with the number of minus signs you have there. Okay, but this is what we have, finally. Finally. Alright. Right, so we have our momentum equation. Finally, like, done. Okay. Again, pardon the careless mistakes, but okay, this is the final result for the time being. This is not the von Karman equation yet. We're about halfway there. Okay. Not von Karman, yeah. It's not the von Karman equation. We're halfway there. We'll need to make another few assumptions in order to get to where we need to get to. Alright, so yeah, this whole video basically is about correcting the careless mistakes, and then we get our final results. Half final results. We're halfway there. Semi-final, if you like. Alright, thanks for watching. See you again.